All right, today's notes, section 8-5, are independent and dependent events. So the probability of something being independent, which basically means that the occurrence of one thing has no effect on the other. So that's the important part, is that there's no effect. An example would be like tossing a coin. If I tossed a coin once and then I tossed it again, that first toss would have no effect on my outcome for my second toss. So toss a coin is one type of example. The formula is going to be probability of A and B, because we're doing something more than once, is equal to probability of A times probability of B. So let's go ahead and look at a few. So basically trying to figure out, does the effect of the first item have any effect on the second item? So for instance, a game machine, like maybe a slot machine in Vegas, claims 1 in every 15 people win. What's the probability that you win twice in a row? So if we think about this, when you win once, does that technically have any effect on you winning again? And the answer is no. It should be independent. Is it likely? Probably not. So you basically want the probability of a win-win. So probability, so you're going to play this game twice. So this is like your first try and your second try. And so it's 1 over 15 for the first try and still 1 over 15 for the second try, since they are independent. That gives you 1 over 225, which is 0.004. So that's super, super close to 0, which means it's probably not very likely. Next example, a bag contains 3 red marbles and 7 white marbles and 5 blue marbles. You're going to draw 3 marbles. Okay, so we have 3 red, 7 white, 5 blue. We're going to draw 3, so we're going to be doing this 3 times. We want the probability of getting a red, blue, and a white. So what's important on here to make it independent is you must replace them. So after you pull a marble out of the bag and you look at it, you got to put it back in the bag. And so that keeps everything independent if it's replaced every single time. So this one will be the probability of red, blue, and then white. So we're going to do first time, second time, third time. So red is going to be 3 over our total, which is 15. And then probability of a blue is 5 over 15. And then probability of white is 7 over 15. So again, every time we put that one marble back in and we redraw, so that's what's making this one independent. When you multiply straight across, you get 105 over 3375. And as a decimal, that's 0.031. So again, not very likely, especially because you're trying to get it in this specific order. The alternative is when they are dependent. So when something has an effect, so this time when I do one thing, it definitely is going to affect the occurrence of the other one. And we'll go through these. This probability is a little bit different. So it's still going to be probability of A and B. So probability of A and probability of B is going to be probability of A times, and so I'm going to offer some new notation. Probability, you're going to do B, then kind of like a division bar, B division bar A. And basically what this means here, this piece here, is basically saying the probability of B given that A occurred. And we always assume A happens. So we assume that A happens. Okay, because I know a lot of times when we're doing these, students are like, but what if it didn't? Well, if it's dependent, we're assuming that we got what we asked for, or whatever we wanted to happen did happen. So let's look how this changes it. So another marble example. So we have 3 red marbles, 5 green, and 2 white. And this time it says, and again, this is the key, it says without replacement. So we're not putting it back. So for instance, I don't have marbles to show, but let's say I was pulling from these 4 pens. I am going to take that marble, so for instance this pen, and I'm going to move it away, and now it's no longer in my sample size to choose from. And then when I take the second one, I'm getting rid of it. So you can see you're decreasing. Versus independent, I take it and I look at it and I'm like, okay, I put it back, and then I go and I take the next one, I look at it and I put it back, so it's not ever changing. That's independent. But for this one, we are not replacing it, so we're going to basically hold it out and we're going to assume that we got what we asked for. So we want the probability of a red, a white and then a red. So probability of white and then red. So the first one is always going to be the probability of A. So we're going to do probability of white. So how can I get a white? 2 out of 10. Now I'm holding on to that one white, like it is in my hand right now. So first thing that you should notice is no longer are there 10 marbles. There are only 9 marbles now because I'm holding this white one. And then how many are red? The number of red are 3, and that's not affected by me holding a white, but the denominator should go down 1 because I'm holding on to it. And that's the biggest change that occurs, is your total will not be the same as it was when you first drew, because again, you are holding on to it. I reduce everything and I get 0.067. So again, you can start to see how when you're doing something multiples of time and you're trying to get it this very specific, it's not always going to work out that way. Like the probability is very, very, very low that this is going to occur. All right, we're going to come back and do the second part of this in just a second.